capacitor is storing charges implies storing energy, right?
Yes, sir.
So we have a capacitor of capacitance C and a battery of potential difference V. Okay, so there is a potential difference V and the capacitance is C. Okay.
Yes, sir.
Now what we said is that the work done is what work done? Work done to deposit the charge on the capacitor.
Yes, sir.
Work done to deposit the charges on the plates of the capacitor is equal to integral of Q into dV. I'll explain Q into dV right now. Okay.
Yes, sir.
There is a charge Q at a time t. At time t, a charge Q is deposited on the plates of the capacitor.
Yes, sir.
Now, in the process of getting charged, the potential difference across the capacitor is changing as the charges are further getting deposited, correct?
Yes, sir.
Originally, now I am telling this story just like exactly yesterday I told you, okay?
Yes,
I
sir.
have 5 coulomb charge, let us say I have 5 volt of potential difference across the capacitor.
Yes, sir.
Some extra charge came. We know for a capacitor, for its potential difference across the capacitor to vary, the charges on the capacitor has to vary.
Sir, and you are already defining that it has five. I mean, you are already defining the capacity of the capacitor.
No, yes, I mean, see, see, the capacitance of a capacitor is always defined epsilon naught A by D for parallel plate capacitors has
Yes.
nothing to do with battery charge
Yes, sir.
which we are putting on the plate.
Yes, sir.
So now follow this example.
Yes, sir.
For the potential difference to exist across a capacitor, there should be charges deposited on the capacitor, no other process.
Yes, sir.
That means, no sir, I have a potential difference of 100 volt across my capacitor, but there are no charges is an impossible statement.
Yes, sir.
I
But
have a
then at
potential
time
difference.
T equal to 0.
At time t is equal to 0, what is the charge on the capacitor?
0, sir.
0. If you remember, here positive charges, here negative charges, here plus sigma, here minus sigma.
Yes, sir.
What is the electric field between the plates of the capacitor?
Sigma upon epsilon.
Epsilon naught. The electric field only exists when there is difference in potential difference.
Yes, sir.
If initially the charges on the plate is 0, what is the field between the plates?
There is 0.
Initially charges on the plates is 0.
The field also
Field is 0. If field is 0, what is potential?
difference is 0.
0. Clear?
Yes, sir.
So, initially when at t is equal to 0, if the charges on the plates of the capacitor is 0, the potential difference across the plates of the capacitor is 0.
Sir, can we tell that potential is only 0?
potential or potential difference is different.
Yes, sir. Like initially, okay, it might have some potential. Yes, sir.
Might potential is a reference frame based thing, right?
Sir, like how?
Potential energy. I told you in terms of potential energy. Potential word always is based on a reference frame, something with respect to something. Potential is nothing but the ability, right?
Yes, sir.
The ability is always a reference thing, right? How do you say the ability of Mike Tyson is the
Okay,
best
like
unless and until he has fought with so many people?
compare it with the other
You
thing.
need to have some reference with respect to, therefore, you can say the word potential. Otherwise, you can't use the word potential.
Yes, sir.
That's the difference between electric field and electric potential. Electric field is an effect. Effect is not reference based.
Yes, sir.
Effect is effect. Basically, if an ant flies and hits me at its natural speed, I will not even know. But a bullet hits me, even then I will not know. But permanently, I will not know. Understand what we are saying right now? Specifically, potential word needs to have a reference. Therefore, I am not interested in speaking about potential. In
Yes, sir.
India, the potential that I want to use, the reference I want to use is 100 volts, sir. Okay. In China, it is 50 volts, sir. Okay. In Japan, it is 0 volts, sir. Okay. How much reference number you want to keep to yourself, on whatever basis you want to keep yourself, is none of our concern.
Yes,
We are
sir.
only bothered about the potential difference across the plates of the capacitor. Is it dependent on the charges, or it has some its own independent story? That's what we are looking at right now.
Yes,
The
sir.
potential difference across the plates of the capacitor is dependent on the charges which are placed on the capacitor, because the electric field is sigma by epsilon naught, which is dependent on the charges deposited on the plates of the capacitor.
Yes, sir.
Just by attaching a battery doesn't mean that capacitor also has the potential difference unless and until charges are deposited. Okay.
Yes, sir.
In the process of charges being deposited on the plates of the capacitor, I am telling you a story. While the charges which are present on the plates of the capacitor is 5 coulomb, let us say the respective potential difference across the plate is 5 volts.
Yes, sir.
We know that the potential difference across the plates of the capacitor will only change when there is a change in charges on the plates. Otherwise, there
Yes,
is no
sir.
potential difference that is going to occur across the plates.
Yes, sir.
Now, by adding some kind of a charge to the plates, let us say the voltage across the plates went to 6 volts.
Yes, sir.
Is the voltage across the plates 6 volts? Of course, it happened because of the extra charge that is added. Correct?
Yes.
Happened due to. But does this 6 volt apply to only the extra charge added, or the 5 coulomb plus the extra charge that is added?
It's 5 coulomb but plus extra.
That means we are saying that whatever new potential difference across the plates that you have brought is applicable to the original one also.
Yes, sir.
Now, if you are making a deer become a chimpanzee, that means you are feeding it something.
Yes, sir.
If the original 5 coulomb, who was like a deer at 5 volts, now you are making it like a chimpanzee at 6 volts, you are increasing the potential difference, you're increasing its ability of the 5 coulomb. That means I am feeding some energy to that 5 coulomb.
Yes, sir.
At any time t, let the charge on the capacitor be q, and when there is a potential difference that is given, of course due to the addition of some extra charge, if the potential difference is given as dV and the charges at that instant are q, then the work that I have done to change the potential difference of that charge q by dV will be q into dV. I'll repeat this.
Yes, sir.
No, this was fast. I'll repeat. Okay.
Yes, sir.
At any time t, let q be the charge placed on the plates of the capacitor. For this charge to go through a potential difference, change in potential dV, it requires some kind of energy. The energy required for the charge q to go through a change in potential difference dV is q into dV.
Yes, sir.
Of course, this dV potential difference is happening because of some dq. Due to dq only this dV is occurring. So the
Yes,
new
sir.
charge which is present is actually q plus dq.
Yes, sir.
Then you can say there is a term dq into dV also, no? Then for that small change in charge also there is a potential difference dV is occurring, right? Change in potential.
Yes, sir.
Anyways, those two are negligible. Differential element into differential element, a differential element itself is a infinite small.
Yeah. Yes, sir.
Differential element into differential element is furthermore infinite small.
Yes,
Is
sir.
clear?
Yes, sir.
So the energy required for the 5 coulomb to have a change in potential difference from 5 volt to 6 volt, I have to multiply 5 coulomb with 1 volt, the change in potential. That much energy I have to give to this 5 coulomb for it to go from 5 volt to 6 volt.
Yes, sir.
5 coulomb into 1 volt. 1 volt is 6 minus 5, that is dV. Correct?
Yes, sir.
This is my Q and this is my dV. So for this Q charge to come and go through a change in potential difference of dV, the energy required is Q into dV. But this process keeps going on as the capacitor is being charged from the charge 0 to the final charge whatever, right? So I'm integrating. Is this clear?
Yes, sir. Then you took TV because, like, for every, I mean, if we take for millisecond, microsecond, whatever, there'll be various, like, a small change. That's right.
I didn't understand.
Third, you took it DV because if you consider for a microsecond or millisecond,
For a small time dt. Yes.
like a very small potential difference would be there.
For a small time dt, actually I didn't write here, but there is dq charge added, right? That also
Yes,
is
sir.
there. I didn't write that also. Due to this excess charge of dq only, the dv is actually coming. But the dv has to come for entire q.
Yes, sir.
For that q to go through a dv is the work that I am focusing on. Because the other dq into dv is a negligible term.
Yes, sir.
And this is happening in that small time dt. But I have nothing to do with dt. I am only interested in the energies related to the capacitor.
Yes, sir.
So for that q charge to go through a dV, what is the energy? Q into dV. This process continuously occurs from the beginning of the charging of capacitor to the end of the charging of capacitor. Therefore, I am integrating.
Yes, sir.
Now I am going to do the mathematics part of it. So in place of Q, I have CV, correct? Into
Yes, sir.
dV. So I am directly writing it as half CV square.
Yes, sir.
So the work done to change the potential difference from 5 volt to 6 volt for a charge 5 coulomb is Q into dV integrated. I'm getting half CV square.
Yes, sir.
Correct?
Yes, sir. And in the initial, like starting, you gave a statement work done for charges to deposit on the plates of the capacitor.
That's exactly what is this, right?
Yes, sir.
The work done to basically add this dq or change. Adding this dq is basically changing the potential from 5 volt to 6 volt.
Yes, sir.
And this sequence is constantly occurring, right? Adding more, adding more, adding more. 5 to 6, 6 to 7, 7 to 8, 8 to 9. What am I doing?
Yes, sir.
I am feeding energy to the capacitor.
Yes, sir.
When I integrate and get whatever it is, I am getting the energy given to the capacitor.
Hmm.
Are you getting my point?
Yes, sir.
When
And the
I
work is being done by charges.
will come to that.
Yes, sir.
Will come to that. We integrated something. We got something. It is great that it is half CV square. It will be used as a formula. Anyways, we have fun with formula. Great. Because the questions are always formula based in JEE. Right? So understand this. Half CV square will sit in everybody's mind. But it is important to know what that it is, right? What is it? Because that's where the questions are going to be tricky. I know formula, substituted, got the answer, A, I got it, yay, plus 4, came home, -1. This is what happens. Unless and until I know what it is. Correct?
Yes, sir.
Q into dV is the energy that is required for 5 coulomb to go from 5 volt to 6 volt. Another Q into dV, another Q into dV, another Q into dV. Ultimately, the addition of all these Q into dVs is the energy that I am giving to the capacitor.
Yes, sir.
Is this clear?
Yes, sir.
Can I say work done on the capacitor is half CV square?
Yes, sir.
Because I already wrote it, it should be right. Tell me, how can I say work done on the capacitor is half CV square?
Sir, in the physics terms.
Tell me any terms. How can I say that whatever I said just now is correct? Work done on the capacitor is half CV square. Why is this statement correct? Because I am a goat and whatever you say, I will say yes, sir. Because that is the energy I am giving to capacitor bit by bit.
Sir, the energy is getting stored inside the capacitor.
The
Again.
energy given to the capacitor bit by bit in terms of Q into dV is integrated. Therefore, the total energy given to the capacitor is half CV square. Therefore, I can say the work done on the capacitor is half CV square.
Yes, sir.
I gave capacitor 100 joules. The work done on the capacitor is 100 joules. Is this clear?
Yes, sir.
Understood.
Yes, sir.
Now we will also understand other things also, like you said, who is doing this? I mean, charges are doing this, obviously. But anyways, so now focus. Work done on the capacitor is half CV square. There is one point over here. In originally also potential energy and work done, that subscript force thing used to be there, right?
Yes, sir.
Now same logic I am applying. Understand this. If work done on the capacitor is 100 joules, the energy contained by the capacitor is 100 joules.
Yes, sir.
I worked on the capacitor and gave it 100 joules. How much will it have? 100 joules.
Yes, sir.
Unless or until it is a politician.
Hmm.
Otherwise, it will have 100 joules.
Yes, sir.
Can I say that work done on capacitor is half CV square? Therefore, the potential energy of a capacitor is also half CV square.
Yes, sir.
Is this clear?
Yes, sir.
By the way, because we have Q is equal to CV.
Sir, and like if we consider with respect to the electrostatics one, we had work done as minus delta U, but then we are taking delta V as like initial
We are
minus final.
understanding that in our statement itself. Yes.
Yes, sir.
Changes my final minus initial. Due to that minus sign, it becomes initial minus final. All those things we are understanding
And
in our
potential difference from starting, we were taking like high potential minus low potential.
Yeah, I mean, all those things are there, but don't jumble everything over here.
Okay, sir.
Energy stories, I told you, are laddus, right? How many
Yes, sir.
laddus did he have? 0. How many laddus did you give? 5 laddus. How many laddus does he have? 5 laddus.
Yes, sir.
Simple. We can just go in that simple manner, right? Unless or until in certain questions where work done and potential energy are mathematically connected and asked, there we have to use our entire whatever knowledge we, not everywhere. Okay.
Yes, sir.
Usually I don't apply everywhere. I don't try to connect it because I will only get confused. Why should I confuse?
Yes, sir.
And especially energy is a easy thing, scalar. 5 laddus given, therefore the laddus number of laddus he has is 5. End of story. I don't want to think any further. Right?
Yes, sir.
So also when we say Q is equal to CV, we can say V is also Q by C.
Yes, sir.
Right? From this we can say V is equal to Q by C, right? So if you substitute Q by C over here,
CQ.
so you can say it is Q square by 2C.
Yes, sir.
Or if you see, you can write this fellow as half C into V. Fellow itself is Q, right?
Yes, sir.
So I can write this as QV by 2 also.
Yes, sir.
The whole idea is, if you ask me what is the potential energy of a capacitor, and if you ask me in terms of 3 different things, either CV or QC or QV, tell me in any which way, I can write, either I will say it is half CV square, depending on what is given in the question, or I'll say Q square by 2C, or I'll say QV by 2, correct?
Yes, sir.
This has nothing to do with concept. This is just boring school mathematics just to play around.
Yes, sir.
Right? Now moving on. Till now we have come to this situation. From 0 coulomb to 100 coulomb, the capacitor got charged. Whoever has given the energy to the capacitor, but at least we have come to understanding that 100 joules of energy is given. That means work done on capacitor is 100 joules. Potential energy of the capacitor is also 100 joules because it has only 100 joules.
Yes, sir.
That much we have established. Now let us come to point that you were mentioning. Who is doing this work? Somebody has to do work. When we are saying work done on the capacitor, there should be someone. I know you know the answer. You will tell it right away to avoid any kind of a taunt. Who is doing this work?
Sir, Q is doing, but how can Q do? I don't know.
Therefore, the answer should be,
I don't know, sir.
who is there in this story to do work?
Only Q is there.
Eh?
I mean,
Look at the diagram. You and me are not there. Someone else is there. Who is giving energy to the capacitor?
Battery.
Done? Clear? Of course not clear, I know that. But you have no other choice. You are like tortured and forced to say who is doing work, who is doing work. Nobody else is there, so I'll have to take the name of battery. Who wrote this on board? Tell me, tell me. There are only 2 students. Yeah,
Yes, sir.
there are only 2 students. One is charge and the other is battery. Now, if charge is not to be blamed, then battery is the only fellow, right? There is no other fellow. Even if I say electron, it is charge only. Now, let us see how this is happening. Charges, can charges do work? Tell me this. Can charges do work?
It does for itself, sir.
When we say charge is doing work or someone doing work, now I am basically lifting this marker. The marker is going up, correct?
Yes, sir.
Who is taking the marker up?
Yes, sir.
Who is making the charge move? Who is making
Due
the
to
charge?
the energy of battery.
Whatever. Battery is making the charge to move.
And that's a conductor.
No
also.
battery, of course, conductor. Conductor, it's like put a big stone on my hand and tell, now lift. Of course, conductor, I want to move, right?
Yes, sir.
All those things are basically related to other things which we will slowly digest in our future. We are not in a hurry. I'm just clarifying that particular part, that charge is like a soldier. Who is sending the soldiers? Mantri is sending the soldiers.
Yes, sir.
So, who is sending charges? Battery is sending charges.
Yes, sir.
Battery is doing work on the capacitor via charges. Who are carrying these laddus and taking? Charges are taking.
Yes, sir.
So, if you think of it in a minuscule way, you can say, yes, charge is doing the work, right? Because charge is taking one laddu and placing on the plate of the capacitor.
Yes, sir.
But actually, how can you say soldier is responsible for war? Who is sending the soldiers? Mantri is sending the soldiers. Who is sending the charges? Battery is sending the charges. So, in a larger perspective, in a proper perspective, if you look at it, you can say battery is doing the work. In a whole perspective, you can say battery is doing the work on the capacitor. In a minuscule perspective, if you are sitting in this gully looking the soldier run, the bad soldier running.
Yes, sir.
Right?
Yes, sir.
If you sit over here
Sir,
just to
we
watch
can
over
also-
here, you will see charges going. Therefore, you will say charges are taking the energy. Who is sending those charges?
Sir,
Please.
can we also tell that battery is like losing its energy, so basically it's doing work.
Battery losing its
I mean,
battery, did it tell that it is losing energy? Who told you battery is losing energy?
sir, by the time all the
Maybe my
charges
battery is like
deposited-
Lord Krishna giving sari, take as much as you want. I don't know who told me that battery is losing energy.
Sir,
That's
by
it.
the time the charge,
See, that is a
Yes.
perspective that you want to put before for anybody telling you, is just to fit in. How many ways can I fit in to get the answer? No. I'm going slowly and step by step. If you sit over here and look at the charges go, you will imagine that the charges are doing the work, because you will see charges running. You will say charges are responsible. Otherwise, why are they running?
yes, sir.
But if you look at it from a full perspective, battery is responsible for the charges to move. Therefore, it's not right that you say that charges are responsible for the energy to be taken, whereas the charge itself is the energy. He is only one laddu going and dying, right?
Yes, sir.
So telling laddu itself is going and sitting in somebody's mouth is a wrong thing. So what I am saying is, if you look at it in a complete perspective, you can say battery is doing the work on the capacitor.
There shouldn't it be chemical inside the battery?
Exactly, battery means the chemical inside the battery, no doubt. Different batteries have different chemicals, and there are more different types of batteries available. Many
Yes.
varieties of batteries available. Therefore, why go inside? Chemical is only the electrochemistry that we wanted to discuss. It just the basic understanding of a battery. Anyways, battery is responsible for the energy to be stored on the capacitor. So, who is doing the work on the capacitor?
Battery.
Battery. Okay, so work on the capacitor is due to battery. Now,
Yes,
don't try to fit
battery
in.
is only giving energy, so
Don't try to
obviously.
fit in any other kind of a thought process that see in this movie we have one battery, one capacitor. Like I said, maybe my battery is Lord Krishna giving infinite sadi. Take. Maybe this battery has another source giving it infinite energy. So let us not fit in some kind of a situation. We are saying the energy on the capacitor is deposited due to the charges that are being deposited. Why are the charges being deposited on the capacitor? Because of battery. Therefore, the charges or the energy which is stored in the capacitor is due to the battery. That's the sequence I'm saying. Here, don't try to fit in any other sequence. Because the story behind the battery, the story can vary. We are not interested what is happening behind the battery. Who is that
That
battery?
is fine, but let's say there is no external agent giving its energy again to the battery. So that time we can tell that, like, if you use
But why do
batteries
you want
with
to
the TV
take?
remotes or
Why
whatever,
do you want
like,
to make your own stories when the story at least reaching to the battery? See, right now we are coming from capacitor, we are walking, and coming back to the battery. We haven't entered inside the battery or seen what is there behind the battery. Right?
yes, sir.
We came till battery and we are saying battery is responsible for the energy being deposited. Why should I dig in deep?
Yes, sir.
Okay. There can be many cases. Then case number one, case number two, case number 100, case number 1000, case number 2000, and entire academic year can be spent. But anyways, why am I interested in what is there behind the battery? Nobody is asking in capacitors chapter or current electricity chapter what is inside the battery. Right? Only one type of a battery that you have in your electrochemistry chapter we discussed yesterday. That's it.
Yes, sir.
Okay. Now
Yeah.
moving on, there is furthermore. There is furthermore. See, there is something that I want to discuss about the conductor and the conduction part. In current electricity, we will discuss. The derivation of Ohm's law itself is that. Okay. What
Yes, sir.
is this conduction happening or what is this conductor? We will discuss in Ohm's law. Here I want to only say, can I say that plus Q charges are being deposited and the minus Q charges are being deposited on the plates of the capacitor this way and that way, correct? Okay. Or if you ask me what is the charge placed on the capacitor, can I say it is Q? Of course, it is plus Q minus Q. But when
It
you're
will be
writing when
neutral.
you're writing Q is equal to CV, C is the capacitance, V is the potential difference across the plates of the
But
capacitor.
then won't it be neutral, sir?
What is neutral?
There's same plus Q, same minus Q, neutral body inside.
Neutral body inside?
I
Capacitor.
mean, yeah.
Capacitor. Plus Q minus Q. Capacitor it is. Two plates not attached.
Yes, sir.
Capacitor. Okay.
Yes, sir.
Now In the equation Q is equal to CV, you are writing C is capacitance, V is potential difference across the capacitor. What is Q? In general, if you want to specify. Of course, plus Q is the charges on the left side of the plates of the capacitor,
It's
minus
like
Q
for both of them, sir.
for whatever. In general, what do we say? Q is the charge on the capacitor, right?
Yes, sir.
In general, I am saying.
Like the
Detail
total
is, of
charge
course, there, plus
deposited.
Q here, minus Q over there. That is 100% correct. But in general, if you want to say what is the charge on the capacitor in general, you will say Q, right?
Yes, sir. Like the total charge.
Every time you are not going to specify plus Q minus Q plus Q minus. Is Q.
Yes, sir.
Understand this. If you look at it in a perspective from the battery perspective, can I say the Q charge which is on the capacitor is going across the battery having a potential difference V?
Yes, sir.
I will give you electrostatics example. A charge Q is present over here. Okay, this is A, this point is B. Of course, the potential difference is V. Okay,
Yes, sir.
this is higher potential, this is lower potential. There is a positive charge plus Q at point A. If you leave it, it will go to B, right?
Yes, sir.
Higher potential to lower potential. What is the work done?
Sir, Q into V.
When a charge Q crosses a potential difference of V, the energy related to it, you know it is work done, but I am saying the energy transactions occurring over there, can I say it is Q into V?
Yes, sir.
When a charge Q goes across a potential difference V, the energy transactions, which we know is work done, is Q into potential difference, which is V.
Yes, sir.
The charge is placed on the capacitor is Q, which of course, if you look at it from the battery perspective, are going by crossing a potential difference V across a battery, right?
Yes, sir.
This clear.
Yes, sir.
This is a circuit, right? Complete circuit you have. In a closed circuit, if 100 crores have come there, those 100 crores have come there through this, right? It's a closed circuit.
Yes, sir.
Those 100 crores which have reached here have of course gone through here. Of course, they are from the conductor, but they have passed via this source, right?
Yes, sir.
Okay.
Yes, sir.
Can I say that these 100 crores have gone through the potential difference of V?
Yes, sir.
If I am now capacitor story is done. Okay, that was the capacitor story. Energy related to capacitor, that story is done. This story is done. Now let us look at this story. But I'm only concerned about this. So the charges that are going on the capacitor is Q, and they are going across a potential difference of V
Yes, sir.
across the battery. So can I say that the work done by the battery, how much charge is going? Q charge is going. How much potential difference is there? V potential.
Yes, sir.
Is this clear?
Yes, sir.
Is this literally clear?
Yes,
Simply, how much charge is going? Q charge is going. Across what potential difference it's going? V potential. Is this really happening or not? You have to realize it right now. That has nothing to do with books or anything. That is our intuition. Is the charge Q actually going across a potential difference of V? I will say yes, and the explanation is because it's a closed circuit. If 100 crores are going, have to go across this only. I said 100 crows are going, but they basically that crows, only the crows sitting over here thought we will go. Other crows said no, we will not go. Did it happen like that? All the 100 crows through the conductor have gone,
But
but they
then
have
that is a capacitor, like when the charges get deposited there instead of like continuously
deposited where.
in the capacitor.
But I am not interested in capacitor now. My capacitor story is done.
Okay, it's like still charging.
I am saying that there is a pipeline connected to my tank to the bathroom,
Yes, sir.
and water is flowing from through this pipe, which is this.
Yes, sir.
Now I am saying I am not interested about my bathroom where I am storing my water.
Yes,
Can
sir.
I say that water is coming from the water tank itself?
Yes, sir.
Or did
Yes,
the
sir.
water decide to come from half the pipe only, and the upper half is like, no, we hartal karenge, we will be no more
Sir,
water.
till now we were telling that like I mean there was plus V and minus V, right? Like the terminals. We were telling for the minus V, the charges go in the reverse direction to the capacitor, and
I'm listening.
sir, over there it's not doing like a full circuit job. It's going halfway around, right?
See, that story was told, and I also told you that it is not just plus V that is doing its own thing. Always it is delta V that always does the thing.
Sir,
I have V plus, I have V minus.
parallel thing
I
also.
understood what you're saying. I have V plus, I have V minus. V plus send somebody, V minus send somebody. Okay, everything is great.
Yes, sir.
V plus has sent red ants, V minus has sent black ants. I understood that story. Can the story be possible only with V plus? Is that anywhere happening in this world?
No, sir.
Story always happens with delta V. For our better understanding is what V plus V minus is where beginning of the story we have started. Without delta V, no story occurs. I have to speak of both V plus and V minus in a story. Only talk of V plus is basically not a right thing to do. But to know exactness of what is happening, V plus story I told.
Yes,
But
sir.
nothing to do over here. What is it to do over here? I am saying I have a closed pipeline. When the water is going through the capacitor, is the water not going through the battery?
It's like two
A
pipes
closed
connected
circuit.
across.
A closed circuit, right?
Yes, sir.
What
Yes, sir.
can I say that halfway through the water decided I will go from here only, no more here? Is it happening that only nearby capacitor plates the charges are saying, okay, we will only come? No, and these fellows, this conductor is showing no more charges flow. Is that happening? The charges are flow. It's a closed circuit. I'm using closed circuit again and again for you to understand. The charge flow is occurring through the closed circuit. It's not just happening in one region. It's not
Yes.
happening in one region. It is happening in the
Sir,
throughout
if
this.
you put a water tank in between and also put pipes arranged in that rectangular
That
way,
is one more battery in between, right?
what?
If you put a water tank in between, that means you're putting another battery in between. No problem.
Not battery, sir. That we can consider as some capacitor. It's storing water.
You can use, okay, then you use basically a capacitor. Now you are studying two things. Anyways, I'm not interested in studying capacitor over here. My capacitor study is done. Why would I use another capacitor to study something else, which I don't have nothing to do with capacitor? The charges that are flown are Q. Can I say that the charge flown is across a potential difference V?
Yes, sir.
Gulp this, not without understanding. I'm saying here we are trying to corrupt ourselves in entering into circuits. Only we will go to current electricity chapter also, which is all closed circuits.
The one thing is bothering me is that from starting till now, we were sending charges from left hand and right hand.
But that's
And
that's my job, right? To corrupt you slowly
third,
and steadily, not corrupt you in a one go.
I'll take that. But
Wait, now let me put it in a different way, and I think that this you will, this corruption would be the required corruption to corrupt you properly. When I am saying in whatever story you use P plus V minus whichever story you want to use, can I say the motion of positive charges is the representation of flow of current? The motion of positive charges is the representation of the flow of current. Yes or no?
yes, sir.
Taking positive charges flow in this particular situation, can I say while the capacitor is being charged, the current I is flowing through the conductor?
Sir, don't go to the circuits thing.
Can I
And
say that? Can I say that while the
that
capacitor is
fine,
being
sir.
charged, positive charges are flowing from the battery towards the conductor, okay, towards the capacitor? Yes or no?
Yes, sir.
Can I say that the current flowing through this particular wire during the during the charging of the capacitor is I in this direction?
Yes, sir.
Because the direction of I is basically representing the direction of positive charges flowing.
Yes, sir.
But of course, my hands and my fingers are unable to stop themselves. They just want to have more fun. Can I say that the instantaneous current that is flowing right now through the other wire is I in the downward direction? Because the flow of negative charges is happening like that. Implies the flow of positive charges is happening like this.
Then they have to collide.
That actually happens. That's why I said I'm corrupting you slowly.
Or they collide.
That's why I'm saying I'm corrupting you slowly. Can I say simple things? Okay, I am saying, can I say this or not?
Yes, sir.
Can I say during charging of a capacitor, current I is flowing in the clockwise direction through the entire circuit?
Yes, sir.
Can I say that this current is also flowing through across the battery?
Yes, sir.
But the flow of current I is nothing but the flow of positive charges which are flowing. Therefore, can I say that the charges Q which are flowing across the battery with a potential difference?
Yes, sir. But the
Current I is
things
flowing through the battery, yes or no?
Yes, sir.
Current I from the beginning of the story to the end of story is nothing but Q charge which is deposited on the capacitor is flowing in the circuit, yes or no?
Yes, sir.
Because I am saying the current I is flowing across the battery, can I say the charges Q which have flown across a potential difference V provided by the battery?
Yes, sir.
Do you feel bad about convinced slightly and corrupted also further? Yes, sir.
Sir, what about minus Q?
Yeah. Minus.
They
Negative
go in other
charges.
direction.
Negative charges are going from this terminal to that terminal, but because the direction of I is the representation of the positive charges, if minus fellow is going there, implies the plus fellow is coming here.
Yes, sir. But the Q will represent the total thing, no, sir.
Correct.
Then why aren't we taking into consideration of minus? Q.
Were we not taking minus Q into consideration?
Yes, sir.
I have taken minus Q plus Q, and if any other non-binary stories are there, everything into account and said that the current flow is I.
Yes, sir.
Right? I mean, of course, here there are only, yeah. So, of course, here there are only positive charges and negative charges. I am saying I am taking everything into account and talking in terms of current I, because you're refusing to get corrupted in an easy way. I'm corrupting you in the most worst way possible. Current I said, I said, negative charges from bottom to up. That means current I is downward, right? Representation. And that current I is flowing through battery. That means my charges are going across battery. And the battery has a potential difference V. How much charges are flowing in the entire story? Q charges are flowing across what battery? A potential difference of V battery. How much is the work done? Q into V.
I don't know.
I also don't know. Is this correct?
Sir,
Is
with
there
respect
anything
to
wrong
the
in this?
electric current, that is fine, sir.
Is there
Not with
anything wrong in this? Is there anything wrong in this?
Sir, with respect to the electric current, there's no mistake. But with respect to the capacitor thing,
No, capacitor is died, dead. That fellow is no more in my story. No.
yes, sir.
Capacitor died long ago. Is there anything wrong in what we said just now? Now ask further doubts. Yeah. Nothing wrong in what we said, right? Or can you identify something wrong?
Sir, how will the minus Q flow?
The flow of minus Q from right to anti-clockwise is represented by the flow of plus from clockwise. Therefore, I am showing current I. Although I am not talking about the minus or plus stories over here, or I am not talking about directions of currents over here, just showing that the current is flowing in the clockwise direction, because the representation of flow of positive charges is the direction of current. But I have nothing to do with what is the direction. I am saying charges Q are flowing across battery V. Therefore, work done is.
Yes, sir.
Now, negative charges going there, positive charges coming here, negative charges, positive charges fighting somewhere in between. Is negative charge stopping somewhere in between? I have nothing to do with it. Negative charges flowing in anti-clockwise direction is equivalent to, not exact, equivalent to positive charges flowing in the clockwise direction. Negative charges flowing in the anti-clockwise direction is equivalent to positive charges flowing through clockwise direction. Are there any positive charges on the negative plate of the capacitor? No. We are not talking of the exactness of the detail. Negative charges anti-clockwise is equivalent to positive charges clockwise. I am not interested anti-clockwise, clockwise, positive charge, negative charge, who is going, not going, whatever it is. I am saying, keeping this in perspective, can I say the total charge Q deposited on the capacitor has gone across battery? Happened or not?
Yes.
Of course, negative has gone somewhere, positive has gone somewhere. Is there any defect in my wire anywhere in between? Of course, there will be defects in wires in between. If you go in microscope, 100% it will. What exactly is happening? Yes, all those things are there. But whatever story we have said, is it correct or not?
Yes.
Can I say the work done by the battery Q into?
Yes.
Getting my point?
Yes.
There is further from here we are going, which of course, whatever doubts when is not a problem. Slowly they will disappear, or they will be cleared, or let's say you will get clarity slowly, because in current electricity also we will do something or the other, right, in our lives. That's why I'm not bothered about it. But till now, what we have discussed, we have only discussed that Q charge has flown across a battery V. Therefore, I can say the work done by the battery is Q into. There is further over here. This Q into V, can I say Q is equal to CV? Therefore, this Q into V, can I say is nothing but CV square?
Yes, sir.
Work done by the battery is CV square. The work done on the capacitor is half CV square. What is happening here?
The battery is doing 2 times of the capacity.
Or we can say half of the money sent by the central government. This fellow sent CV square. That fellow received half CV square. Where is the other half CV square?
Maybe it was getting lost.
Where? Correct, it is getting lost at. Is the lost energy. Where is it
So
losing?
maybe kinetic energy because charges are.
See, I know English doesn't mean I fix any word anywhere. You said energy is lost, then you said kinetic energy. Why are you saying kinetic energy is lost? Lost
No,
energy is kinetic energy.
oh,
Lost is something, meaning is different. You brought word kinetic energy here. A person was walking in a jungle and a rattlesnake bit him and the kinetic energy is 0. Just because I know English, fit in any word anywhere. You know something is lost. Now, where do you think it is lost? Who is giving? He is giving. Who is receiving? Who is storing? That fellow is storing. What else is remaining in this story?
there is the middle wires.
Middle wire. In what way is this energy lost? Of course, now you realize that there is only middleware. You can't have any other answer available. You can't. That's why I said rattlesnake bit kinetic energy is 0. Hence, the atoms which the nuclei broke and neutrons came. What you're talking? There's no other thing here except to have that there is some kind of a loss in energy while the wire. Right? The energy lost when the current I is flowing, or when energy lost when charges are flowing through the wire, is half C. But where is it lost? In the wire, we know. In what form?
How? I'm thinking.
What? I didn't understand. What?
I'm thinking, sir.
So, in the wire is correct. Energy lost. Energy lost in the wire is half CV square. In what form is it being lost?
Third, when it transfer, I mean, like
But
when
again,
charges
you
are.
go to rattlesnake going, biting that person, kinetic energy 0, neutrons jumping here from there, then positive charges, negative charges started dancing, and then y square is equal to 4ax parabola came. Arey Baba, I am saying this fellow 100 apples are lost. From Kashmir, they sent 200 apples. I received 100 apples. There are 100 apples lost in between. Who? Where? Are they gone? Somebody ate it in between. No, obviously. Bhagwan. Arey, somebody ate it in
Yes, sir.
between. In this case, the heat lost in the wire is half CV. Who ate it and what is the form? Even what is possibility to energy to transfer itself over here in energy can either
Will
be
consume it.
They're created, not destroyed. Who consumed it? Energy converts from one to other. So from
Yes,
the
sir.
so this energy,
Electrical energy.
electrical energy is there everywhere. This entire thing is electrical energy only. We are in electricity only. Okay.
Yes, sir.
It is lost, right? Somebody ate it. So where did it go? Heat energy. Okay. In any wire, when energy is lost, it is lost only via heat energy. Or you can say radiation also, which again happens due to heat. Okay.
I
So,
thought radiation, but then I thought it wouldn't make any sense.
yeah, I mean, radiation directly will not make any sense. The heat dissipated in the wire or heat lost in the wire, also you can say the heat dissipated in wire or the heat energy lost in the wire. All of this basically is half C square. Is this clear?
Yes, sir.
Xerox. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.